Hello everyone. Now let us start with the 16 group elements again from P block elements, class 12th, chapter 7. Now here we will do the ozone. Ozone, you know well, has the molecular formula O3. It is the allotrope of oxygen. It is the only one of allotrope of oxygen. Oxygen exists as O2 and oxygen can exist as O3. Now, when you will look for the structures for the ozone, it has the bent structure. And band structure is because of the presence of one lone pair of electrons present in the middle of the oxygen atom. And because of that reason, you can see there is a lone pair bond pair repulsion takes place and the structure will be bent structure other than linear structure. Now here, you will see the hybrid structure for the ozone because the ozone in which the OO bond length is same because these are exist in the resonance. The resonance will be takes place between the two oxygen atom, and because of that reason this sp2 hybridized and this is sp3 hybridized, but the bond length will be the same, and it is because of the equal distribution of the electrons among all the three oxygen atoms like this, and this is the hybrid structure for the ozone molecule. Now when we will look for the importance of the ozone, you know well, it is a protective blanket around the earth and it will save us, it will protect us from the UV radiations, which is very harmful and may causes the skin cancer. Now if we will see the preparation of the ozone, ozone can be prepared with this equation. As you know well, the ozone gas will be rupture in the ozone layer will be rupture in the atmosphere itself. Whenever the oxygen is present in the plenty amount and the atomic oxygen is react with it, and it results in the formation of the ozone molecule. But this ozone molecule is highly unstable molecule and it can be deplete easily. It is because of the thermodynamical reason in which you have seen that if the delta G is negative, then the reaction is spontaneous and the product will be stable. But in case of preparation of the ozone molecule, during this reaction, we will see that it is an endothermic reaction. And for the endothermic reaction, delta H is positive. And for the preparation में अगर आप देखेंगे तो delta S will become negative. How is it? You have seen in the 11th standard thermodynamics chapter that when the three gas molecules will be converted into two gas molecules, then there is a randomness decreases because delta S will explain the randomness of the compound, randomness in the reaction. So delta S is negative. As you know well, the relation between the delta G, that is delta H minus T delta S. When we substitute these forms, you will find that at any temperature, the delta G will comes out to be positive. And this is the condition for the non-spontaneous reaction, and this will indicate that the product will be unstable. So that we can easily see that the O3 will be deplete easily, and during the depletion, it will be converted into O2 and release the one nascent oxygen. This is the nascent oxygen, which is a free oxygen and responsible for the oxidation. And because of this oxidation, it will be considered as an oxidizing agent and it will oxidize the other substances. There are so many reactions in which by which we can explain that the O3 shows the oxidizing behavior. The one of the reaction is which is takes place in the supersonic jets. In the supersonic jets, what happened? The NO is react with the O3 that will be converted into NO2 and liberation of oxygen, O2. Now here you can see the nitrogen is present in +2 oxidation state, and here the nitrogen is present in +4 oxidation state. So you can easily see that nitrogen is going to be oxidized here, so that O3 is an oxidizing agent and it will release the one oxygen and it will be enter in the NO, and you will get the NO2 molecule that is in the oxidized form. And this is the reaction takes place in the supersonic jets, which reaction can be asked in the examination also, and this will also responsible for the depletion of ozone layer. Now another reaction we can consider the reaction with the Ki molecule, in which the Ki molecule will be oxidized into I2, where I is present in -1 oxidation state. Here the I2 is present in 0 oxidation state, and the liberation of oxygen will be there. So the nascent oxygen is responsible for the oxidation of I negative from the Ki solution to liberate iodine, which is a violet vapors. So why the violet vapor will be formed? When the Ki is react with the ozone, it is due to the formation of I2 molecule. Now the another reaction you can see, that is the reaction with PBS. In the PBS, when the oxygen ozone layer will be ozone will be reacted, it will result in the formation of PbSO4, and there is a formation of oxygen gas. So introduction of the oxygen in PBS, and the O3 will be converted into O2. So in this manner, we can say that ozone is a strong oxidizing agent. Now, another topic regarding the ozone is the qualitative or the quantitative estimation of ozone. So this is a qualitative estimation, and here we will do the quantitative estimation. Quantitative estimation means how much ozone molecule is present. But you can see the ozone is a gas. So if the ozone is a gas, because of weak intermolecular forces, weak van der Waals forces, ozone molecule is a gas. So how can we determine how much oxygen gas is present in the atmosphere or any other else? So here we will react the ozone molecule with the Ki molecule, Ki compound, and which is buffered with a borate buffer. Buffer means there is no change in the pH of the solution. As you can see, there is a liberation of OH negative ion, and which can change the pH of the solution. To maintain the pH solution at the 9.2, we have to use a borate buffer, so that the buffer solution will absorb the extra OH negative ion, and it will not change the pH of the solution. That you have done in the equilibrium chapter. What do you mean by the buffer solution in 11th standard? Now, when the ozone molecule is react with the Ki, there is a liberation of I2 molecule. This I2 can be titrated against a standard solution of sodium thiosulfate, and the titration is a method of quantitative estimation of the compound. So we have to find out the volume of the Ki solution, how much Ki solution will be there. आयोडीन जितना लिबरेट हुआ उतना ही ओजोन मॉलिक्यूल था, because ozone molecule is responsible for the liberation of I2 molecule. So in that manner, we can identify the how much ozone gas is present in the sample. Now this was all about the ozone molecule. Now the next compound is sulfur dioxide. The sulfur dioxide has the same structure as that of the ozone molecule, that is the bent structure, in which both the SO bond lengths are same, again due to the resonance, and there is a presence of one lone pair of electron. This question may be asked in SO2 molecule. How many lone pair of electrons are present on sulfur atom? That is, the one lone pair is present, and again there is a lone pair bond pair repulsion is present like O3 molecule. Now the SO2 can be prepared. It is very simple to prepare the SO2 gas, that is the sulfur. The yellow colored compound, which has the crown shaped structure, is react with the atmospheric oxygen, and there is a formation of SO2 gas. So we will discuss about the properties of the SO2 gas. Now, first of all, we will discuss about कि SO2 is acidic in nature. You know well, acidic oxides are the oxides which can release H positive ion in their aqueous solution. Since in SO2, sulfur is non-metallic in nature, and non-metal oxides are acidic in nature, which can be shown. I have shown in the earlier that when SO2 is react with the water, there is a formation of sulfurous acid, and sulfurous acid will give rise to the formation of H positive and SO3 2 minus, and it is one of the component of acid rain. The another components are H2CO3, which is prepared from CO2, and HNO3 can be prepared from NO2. All these gases are present in the atmosphere. So whenever the pollutants will contain these gases, it will causes the acid rain, which can causes the itching in eyes, and the historical monuments. It is very harmful for the fields also. It can change the nature of the soil, so that it will affect the production of the field products. Now the SO2 can be act as a reducing agent. Normally when the question will be asked कि SO2 का behavior क्या है, SO2 can be oxidizing agent as well as reducing agent, because it is present in the +4 oxidation state that I have told you in the earlier lecture. So yeah, here we will see how does it react with the reducing agent. Now SO2 can be oxidized itself into the SO4 2 negative, in which the sulfur in the +4 oxidation state converted into sulfur in +6 oxidation state. So whenever it react with the iron 3 salt, Fe3 plus salt, Fe3 plus will be converted into Fe2, and you can easily see that there is a oxidation of the SO2 and there is a reduction of Fe3, so that we can say that SO2 is behaves an oxidizing agent, reducing agent here, because it will oxidize, reduce the Fe+3 ion. Now when it react with the KMnO4 solution, the KMnO4 solution is dark pink in color. It is in the laboratory. You can see easily during the practical examinations. And you have to do the titration with this KMnO4 solution versus oxalic acid and versus Mohr salt also. So the color you can see from the lab. When the KMnO4 solution is react with SO2, there is a reduction of Mn plus 7. Whenever we will see MnO4 negative, we can calculate the oxidation state in this manner. That is x minus 2 into 4 is equal to -1, and x is comes out to be +7. So here the Mn is present in +7 oxidation state, and it will be converted into +2 oxidation state by gain of 5 electron. So that we can say that the coloration of KMnO4 will be decolorized. It is pink in color and it is colorless. So in that manner we can say that SO2 is also act as a bleaching agent, which can be decolorize the colorful material. So SO2 cannot be used with the colorful materials or the आपका उसको प्रोटेक्शन के लिए आप उसको यूज नहीं कर सकते SO2 को फॉर द कलरिंग, otherwise it will decolorize the materials. Now this reaction also shows that it is a reducing behavior. This reaction also shows that it is a bleaching property. Bleaching property भी show करता है, and this can also be used for the detection of SO2. So the one reaction can be explain the three characters, that is a reducing agent character, bleaching property, and it can also be used for the detection of SO2 gas. So whenever we will want to be know it is SO2 gas or any other gas, we can pass through the KMnO4 solution and we can see that it is decolorize the KMnO4 solution, so that we can say it is a SO2 gas. Now we have discussed over here about the sulfur dioxide. We will discuss the one question regarding the sulfur, that is sulfur is exist in the acid form. Already all of you know well. In acid form it has the crown shaped structure, जो आपने पहले भी किया है. Now this crown shaped structure में S8 molecule is diamagnetic in nature, means it has no unpaired electron. Now the question maybe arises कि in which form the sulfur is paramagnetic in nature. This question is very important. The sulfur is paramagnetic in nature in S2 form, which can be appear in vapor state like O2. As from the 11th standard, you have done the sigma 1s, sigma star 1s, this kind of the energy level diagram, energy level sequence regarding the molecules in MOT theory. So in O2 molecule, the two unpaired electrons are present in the anti-bonding molecular orbital. If the two electrons are present in the anti-bonding molecular orbital like O2, because both are present in the same group, so S2 also contain the two unpaired electrons in anti-bonding p orbital. Anti-bonding p orbital like 2 pi 2p, pi star 2px1 and pi star 2py1. Because of these two unpaired electrons, the S2 molecule is paramagnetic in nature, and in which state? It is in the vapor state. So only the oxo acids of sulfur and the preparation of H2SO4 has been left over there, and we will complete this 16 group element in the next lecture. So till then, complete your work and collect your doubt.